Hello and welcome to part 2 of the PV Soil webinars from Valentin Software. Today we will present you the 3D planning in PV Soil Premium. My name is Sixten Fiedko. I'm one of the hosts of today's webinar, and with me is my colleague Thomas Medeke. Hello, Thomas.
Yeah, hello, Sixten. Hello to all participants. Thank you for joining us today. Yeah, like last day on Tuesday, we will start with a short introduction, a short presentation about the content of today's webinar, and afterwards we will change into the software to show you live how the 3D planning works. Thank you.
Yeah, what can you expect today? So we will focus really on the 3D planning. We will show all the things around the 3D, like for example, selecting of climate data records or the
load
economics, etc. You just will show the planning of the real PV system in 3D. There are different options. One is we call it the classic way. You can use one of the existing predefined objects and buildings in the planning, and then you just have to enter the dimensions of your specific object. Then we will also show the module coverage and also mounted systems you can use for the planning. And of course, we will configure everything. And then there are more, I would say, modern ways to design objects and buildings. And this, the first one is by using the Bing or Google Maps, or there are some local providers which also have maps provided in the software. But you can also use digital image, which you can import, and you just draw the outlines of the building and then you extrude it, and that's the way how you can get your object or building. And the last way is to plan with a 3D model, which can be imported. It's a little bit different compared to both other options, it seems to be easy because you don't have to design anything in the PV Soil. But of course, you need to have a 3D model at first, which you have to create in another software. And there are some specific things that you have to consider if you plan with it. Okay, I think that's it for the introduction. Let's go into the program. A short reminder, in the upper part, we see the icon bar here, and the icon bar represents the workflow of the planning. We go from the left to the right. Currently, it's the workflow for a 2D planning, but we want to plan in 3D. So we first have to change this here. We go to the Windows System Type, Climate and Grid. And here we decide that we want to use the 3D design. So we set the hook. Then we will see that the icon bar will change, or is changing. Now we have the new icon, 3D design. We click on it, and then we have to open the 3D visualization, and this can be done by edit or by clicking on the picture in the center here. Okay, and then it opens, and we have to decide what plan we want to use.
Yeah, this is the first step. You have to decide about the coverable object you would like to use. Sixten has mentioned map section and imported 3D models. The more modern options you have, and the more classic way is, if you are using one of these simple roof areas with a rectangular or trapezoidal roof shape, we have available predefined buildings with different roof types: flat roof, pitched roof, tented roof, hip, half hip, gabled, mansard roof, and also a high-rise building is available where you can cover the facade as well as the coverable object on the roof. Also, walls can be covered and open areas. We have also tilted open areas up to a tilt of 60 degrees. We would like to start with a more normal building, a common building with a gabled roof. You have to mark these, select these, and after click on Start, you are in a 3D visualization. And here again, you will find different planning steps. We are now in a terrain view, and the terrain view is to scale the building, to enter the dimensions. You can also change the texture from a roof as well as from a facade. You can add further 3D objects. This could be shading objects as well as further coverable objects. And let's start. This can be done by double-clicking the building or right mouse click edit. And then we need to enter for the story, the width, the depth, as well as the height. And in the lower parts, orientation. 180 degree corresponds to south, 90 degree would correspond to east, and 270 degree would corresponds to west. Okay, the width of our building should be 15 meters, the depth 12 meters, and the height is still 6 meters. Then we need to change to the next step here to attic story. And again, for the attic story, of course, we have to enter the width. So this should be the same as for the attic, for the story. It's 15 meters, but the total width is 16 meters, and this is due to the roof overhang. There's a roof overhang predefined for the left-hand side and for the right-hand side for the overhang on the eave. Also for the overhang on the eave, it's half a meter, and so in total we have 16 meter for the width. Then we come to a point where planners are confusing a little bit, and this is the depth. You don't have to enter the depth. We have to enter the shift of depth. And shift of depth means the position of the ridge. If we rotate the building by 90 degrees, then it will be clear. This is the meaning here, shift of depth, the position of the ridge. And in this case, it's not in the middle. We have not an equilateral roof. We have different roof wings, a long one with a small inclination and a smaller one with a higher inclination. And if you set this to centered, then it's the same, then it's equilateral, and both roof wings are equal. The depth you only have to enter if you would like to add the second attic story. If you have maybe different inclinations in your roof, and then you need a ground area for the second story. And if you enter here, for example, 5 meters, then you can see that the ridge is extended. And you have a ground area, and on this you could place a second attic story. In all other cases, you don't have to enter depth, you have to enter the shift of depth. And please keep in mind, shift of depth means the position of the ridge. Okay, then we can change it back here to 180. Orientated to the south, and now we have entered all our dimensions and also the position, the orientation of the roof, and we can move on with changing the textures. For example, if you would like to do this, you can do a right mouse click on the area we would like to change, and then you have to select change textures. And for the tiles, we have red and black ones, or also slate shingles would be available here, and we would like to use the black ones. Okay, another option is that you can use your own texture if you want. For example, you can do an image, a digital image from a front view of a building, and this could also be placed here on one of these areas, for example, of the facade here. Again, you have to do a right mouse click. You have to select change textures. And now we have to create the textures here of the surrounding area. We have to create these textures individually. And there's a checkbox, and then it will be separated front, left, back, and right surface. And then for the front surface, we would like to use one of our own textures. And if we do so, you have to click this small gear icon here, edit texture, and then we have to load the texture from our hard drive. You have to press on new, and it's stored on desktop, webinar, 3D planning, and this one here, this is our front view. It's an image file, JPEG, bitmap, or PNG. You have to open it. You can see the preview, and then you have to enter the tile dimension. It's 15 meters in horizontal direction and 6 meters upwards. And then we have to confirm it's okay. We have to close, and here we are. Now we have a very realistic view of our house. Okay, now we would like to add a second coverable object, a roof with pitch roof. Here on the gabled roof, we would like to install a flush mount installation, roof parallel installation. And now we would like to add a second story, a roof with pitch roof, and for a mounting system for a rack system. And therefore you will find in the upper icon bar on the upper left-hand side a drop-down menu with different roof types. Again, the one we know from the beginning, from the start of the 3D visualization. And via drag and drop, you can select a roof with pitch roof, for example, holds the mouse key pressed, and then can drop it in a terrain. If it's green, everything is fine. If it's red, then you are in one of these restricted areas or in one other building, and then it's not possible to drop it. Okay, now it's green, everything is fine. And of course, now we have to change the dimension a little bit. This should be a small garage. And again, we have to do a double clicking or right mouse click edit. And here, in case of this building, in case of a pitch roof, this is a more simple roof, like a flat roof. And there's another mode of entering the dimensions. For the gabled roof, we have used the complex mode, and here we have the option to change to the simple mode. And then it's much easier to define the building. You only need the length of the eave, the distance from the eave to the ridge, the height of the eave, as well as the inclination of the roof. And in our case, it's 8 meters for the length, 5.5 is the distance from the eave to the ridge, should be 3.3 meters high, and the roof pitch should be 5 degrees. And the orientation, this is still to the south, to 180. And in the lower left-hand edge, it's also possible to define the position of your building by entering the X and Y coordinates. We have -23 and 0. And here we are. Now we have two buildings. To shift the scene a little bit to the left, you have to press the right mouse key, hold it pressed, and then move from the right to the left. And so you can center our buildings here in the middle of the scene, or in the center of the scene. Okay, now what else we can do? Of course, we can change the texture here for the second building. That's like the first building with black roof tiles. And now I would like to add further shading objects. We have two types of trees available here, a leaf tree and a pine tree. Drag and drop it in a terrain. And as before, for the buildings, you can double clicking it to enter the height and the height of the crown. For example, the total height of the tree can be entered, as well as the height of the crown, the diameter of the crown, the center of gravity, the shape of the crown can be changed, and can define the tree trunk and the transmittance degree. This is the difference between both of these trees. The transmittance degree is for the leaf tree is high during winter time, January and December, because you have no leaves in the crown of the tree. And during summertime, when all leaves are available, then there is only a transmittance of 10%, for example. Okay, now let's enter the dimensions. I think it's 12 meters total height, 10 meters for the height of the crown. The diameter of the crown should be 5 meters, and your center of gravity 0.1. That looks like this. 0.9. That looks like this. And if you would like more like a globe, then you have to enter 0.5. But it should be 8 meters, otherwise 8. Otherwise it's a little bit too big. Yes. And the tree trunk should be 0.4 meters. 0.4. Here we are. Okay, so position is also important due to the shading on top of the roof. It's 5 in X and 1.04 in Y. Okay, now we change to the pine tree. As I've mentioned, the difference is the transmittance degree. Here it's the same for the entire year. And for the leaf tree, you have changes during the seasons. Okay, let's enter the dimension. It's 50 meters 10 meters for the crown, 2.5 diameter for the crown, and this is also 0.5, and the tree trunk, because the tree is a little bit higher, is 50 centimeter, and the position 1.5 and 10 meters. 1.5 for X and 10 for Y. A nice option here in the 3D visualization is that you can copy objects, also buildings with covered with modules and configured. But it's also useful, if you have objects like trees or windows, if we are on a roof. And this can be done via right mouse click, copy, and then the clipboard will be open. And from the clipboard, you can drag and drop as many objects as you want. Here's also available the option make multiple copies. And then the clipboard will not be closed automatically after you have one further object placed in the terrain. It's still open until you close it here via this cross on the upper right-hand side. In our case, we have only one further deciduous tree, and then it will be changed automatically. We have not checked multiple copy. Okay, now I have to enter the position, and it's minus 19 and minus 6, I think. Yes, minus 6. Okay. Okay, that's it for the terrain. Now we have defined two buildings. We have changed the textures. We have added a second building for a rack system, and we have also 3 shading objects. And now we would like to focus here on top of the building with the gabled roof to define shading objects as well as barred areas directly on top of the roof. And therefore we have to activate the building. And afterwards will be changed from the terrain view to the object view. Okay, right mouse click, activate, and then we can move on.
Yeah, so now we have focused on the roof view south of our building 1, and it works the same like in the terrain view. We can drag and drop objects which we want to place on our roof. There are different objects available here. As you can see, there's a chimney, for example, or vent. Just click with our left mouse key and hold it, and then drag it here and drop it on our roof. What else do we have? We have different types of dormers, and then we have single sawtooth roof, fireproof wall on the projecting roof for facade, and then we have a parabolic antenna which we use. If it's green, we can drop it. If it's red, then we are outside our object, and we cannot our roof, so our activated roof or area, and then we cannot drop it. Then we have different types of windows. We have skylight, which we now use, and there's also a door, for example, if we want to plan on a facade. Okay, drop this one here. Then there are different types of restricted areas with different shapes. There are also 2 objects for collectors, a flip plate and evacuated tube collector, but they are just restricted areas. You cannot calculate solar thermal systems with it. What else do we have? We have parapet wall for flat roof buildings, or for several sawtooth roof for industrial buildings, which can be created. And then this is for the edge distances, so the area here at the edges of the current area. So this. What else do we have? We have maintenance paths can be created, and we can also show the dimensions here of the activated roof. Okay, now we have some objects here on the roof. We have to edit them. It works again with right mouse click, edit, or double click on this. And the first one is 0.4 times 0.4. The height is 1.2. And then we position it with 1.2 in X direction and 6 meters in Y direction. And the point of origin here is the 0, 0 is the lower left edge here of our activated roof. This is 0, 0. Then we go 1.2 meters to the right and 6 meters up to the lower left corner of our chimney. Okay, let's go to the parabolic antenna. Double click, and diameter of the reflector is 1.2 meters. The height also 1.2. Then we have to enter the orientation of the reflector. It's important for the shading, of course. It's 130 degree in this case. And then again, the position, that's 14.56. So what's left? Our skylight. Okay. Double click. And then it's 1.8 times 2 meters. And the position is 4.1 and 3. Like Thomas have mentioned it, we can also copy objects here. Yeah, so right click, copy, and in this case we use the multiple copy option here. Yeah, and then we just drag and drop it from the clipboard object. So if you have the same objects on other areas, then you can just move around here. Yeah, the clipboard will be open or will stay open. Yeah, so, and you can move around by using the gray brown arrows, which you can see at the edges of the areas, and with that you can change the two different areas to the facade, etc. Yeah. And if it's enough, then we close the clipboard. So now we move around with the arrows. We are now back on roof view south and just position the last one here. That's 10.2 and 3. And yeah, that's it for the objects here. We have some BART areas with the skylights, and we also have some shading objects with the chimney and the parabolic antenna. So we don't want to have any further object on our flat roof. So we can move forward to the next planning step, and it's the module coverage. And here we have to select the module which we want to use, and also, of course, cover our module or roof area here with modules.
Yeah, up to now there's no active module selected, so we have to select a new module. You have to press the second icon from the left-hand side, and yeah, here we are. We have two drop-down menus, one for the manufacturer and one for the module type. And as described on Tuesday, you are able to limit down the huge number of module types from 16,000. You can select only from favorites, and it's limit down to your favorite and the dummy module, the default module which is available. And if you uncheck select only from favorites, then of course you will have access to all manufacturers and all module types. And here on the upper right hand side there's a detailed selection icon, and then we are here in the PD module database. And as you know, we would like to use a module from LG. You have to click on the manufacturer, and here are all available module types. And the one we have set as favorite, this is the one with the orange star. And if you would like to add further modules to the favorites, then you have to click the stars that these will be orange. And if you would like to use all module types from this manufacturer as favorites, then you have to click the star in front of the manufacturer name. As this is manufacturer independent, you can change to other manufacturers and can select modules, maybe 5 or 10 from each other manufacturer, and it can also be done for inverters, battery system, as well as feed-in tariffs or from grid tariffs. This is also possible. Okay, this is the one we would like to use, not the 3295. The 305 is the one we would like to use. Then we have to click on OK. And now we have 3 options to bring the modules here on top of the roof. Again, you can drag and drop single modules, each by each. This would be possible. If it's green, you can drop it. If it's red, then you are in one of these restricted areas, chimney or the skylight, or you're not completely on top of the coverable area. This could be also the case. And another option would be that we fill only an area, not the entire roof. Then you have to draw a frame, and only this frame will cover these modules. And if you use one of these options, fill area or cover, then you have to define the distances in horizontal and vertical direction. For the fixing material, this is in typical 0.02 meters, 2 centimeters. And you also have to decide about the installation type. Is this a flush mount installation with good rear ventilation, or if it's a building integrated without or with ventilation? It can be also be mounted on a roof or mounted in open space, or floating PV would be also an option. In our case, it's a flush mount, good rear ventilation. I have to confirm it's okay. And now I have to draw the frame. With the left mouse key, I hold it pressed and then move it from the upper left to the lower right. And then only this part will be covered. And the third option is cover. This means that the entire roof will be covered with modules, taking into account the shading as well as the restricted areas. And again, of course, you need to define the distances and the installation type. And here we are. This is our module formation here on our roof. One of the big advantages, in addition to the visualization, of course, and the additional planning modes, is the detailed shading analysis. And here's the first step, the shade frequency calculation, which means the direct irradiation reduction over the year. You will get for each of these modules, you will get a percentage. And that you will get an impression how the shading situation on a roof is, and if you have maybe to pay attention that modules which are shaded are configured in one string, or together in one string and one MPP, and therefore you can use it. And as expected, we have a higher direct radiation reduction close to the parabolic antenna and into the chimney, and of course here in the lower left-hand edge, because we have 2 trees in front of the building. And now we have to decide if you would like to remove one of these modules or not. You have to pay attention here, or keep in mind that the direct radiation reduction is not the same as yield reduction due to shading, because it depends on the time when you will have this direct radiation reduction. Is it during winter time when the radiation is low, then it's not that high impact. And if it's during sunrise or sunset, then again, it's not that important if you have a shading. But if it's at noon during summertime, then of course shading will have a higher influence on the yield reduction. Okay, we would like to remove 2 modules, the one here close to the parabolic antenna, and then we have a symmetric module formation. We also remove the one close to the chimney. You have to click the module, you have to press the control key, and then you can select more than one module. And by clicking the remove key or delete key on your keyboard, you can remove the modules. Okay, now this is done, and now we would like to activate the other building with a more flat roof. And for this, we would like to define a module mounting a rack system. So here in the tree view, now we have to activate building number 2, and then again we are in the object view of this building, but we have no restricted objects here, and so that we can move directly forward to the module mounting.
Yeah, that's right. And currently we don't have any mounting system, as we can see, so we have first to define one. This can be done with the second icon here from the left-hand side, new assembly system. We click on it and a new window will open. And on the left-hand side here in this window, we see the 3 possible options we have for our mounting systems. First one is called PV Soul tilting of modules. That are systems which only have one orientation and one tilt. Then we have the PV Soul East-West tilt. That are the systems which have two directions, typically to the east and to the west, and relatively low mount angle, maybe 10-20 degree. And last but not least, the facade tilt. If you want to plan on the facade, with the mounting system, then you have to use the third options here. Okay, let's come to the right-hand side here. And in the upper part, we have to select our module. Yeah. Yeah, it's currently there is one activated, the one we have used for the module coverage. But we don't want to have it in a vertical direction. We want to have it in a horizontal. So we use this button here to change this to horizontal. Okay, then we have 3 sections: module mount, orientation, and placing. So let's start with the first one, with module mount. And here we have to define the number of modules in a vertical direction. On the roof, we have typically just 1. But if you plan on an open area, then you have sometimes 2 or 3 in a vertical direction or each other. Yeah, but in this case, we let it at 1. In the next 2 fields, you have to define the spacing between the modules in horizontal and vertical direction. And then we have the height of bottom edge. So this is the distance between the roof in our case here and the module. Yeah, and yeah, it's typically relatively low on the roof. It's 0.1 meters in this case. But if you plan an open area, then you need probably a little bit more space because you have to cut the grass and or what else. Yeah. Okay, first section done. Then we can go to the orientation. And in this window, we have to define the values for the mounting system itself. So we have to define the mount angle of the mounting system. In this case, it should be maybe 20 degrees, for example. And the orientation of the mounting system. And the orientation is defined in relation to the reference edge. You can see here we have the reference edge 1. So that are the yellow numbers here at the edges of the area. And edge 1 goes to direction south. And if we want to place or orientate our mounting system to the south, then we would have to enter here 0 degree, because we want to face the same direction. If we want to face in direction east, then we would have to enter a minus 90 degree, and to the west it would be plus 90 degree. Another option would be if we change the reference edge. So we can see here the default edge, it's typically edge 1, but we can also change to edge 2 or edge 4, and then it would be again 0 because we want to face in the same direction. If you are unsure what to do here or what to enter, then you can use the calculate icon here. And here in these 2 fields, we have to enter the resulting module inclination and orientation we want to have. So in our case, we want to have 25 degree, and it should be facing south, our module, and it's 180 degree. And as we can see, we have an inclination of the mounting surface, the roof, of 5 degree, and the orientation is to the south. And this gives the result. The mount angle of the mounting system itself should be 20 degree, and the alignment in reference to the reference edge should be 0 degree. The reference edge is always at 1 in this case. Okay, and if we press OK, this values will be automatically adapted here into the 2 fields. Okay, let's come to the last section, placing. This is basically to define the distance between the module rows. You can enter distance here. You can also calculate the distance, and then the software calculates for a specific date and time. It's on a northern hemisphere for the 21st of December at noon. So this is the time with the lowest sun height at noon of the year. And for this specific time, the software calculates the distance so that you don't have any shading. And in this case, it's D1 here and it's about 0.9 meters. Of course, during other times like sunset, sunrise, you will have shading, but it would make any sense to use this times because then you would place maybe just 1 row on the roof. Okay, if we press OK, then the 0.9 will be automatically adapted here into the field. So we press OK. Our mounting system now is created or defined. And what we now have to do, we have to place it, of course. Same three options. We can use place single rows, we can draw a frame, and we can cover the entire roof here. So for drawing single rows, we have to define the horizontal modules, or the number of horizontal modules you want to have. There are some predefined ones here. If we click on the number, then we can enter our own number of horizontal modules. Then we just drag and drop it here. If it's red, we cannot place it. If it's green, then we can drop it, for example. It's possible. Again, the frame is possible, but we just cover it. Okay, here we are. That's our modules, and we can place it by moving it with our mouse, or we can also use the position again by right-click and then edit array. And it should be 0.7, I think, and 0.5. Okay, now we have covered both of our buildings. We have to move forward to the configuration to find the suitable inverter.
Yeah, and therefore we go back to building number 1. We need to activate it. And then we go to the tab here, module configuration. Yeah, and again, we have different options. The first one is to configure all the modules only visualized here on this coverable area, on the gabled roof. And the second one is to configure both module areas together. Yeah, the flush mount installation from the gabled roof, as well as a rack system on our more or less flat roof. And this is what we would like to do. Therefore, we have to click the second icon from the left-hand side, configure all unconfigured modules. And here we are in the inverter window. And yeah, to configure both areas together, we have to mark also building number 2. Therefore, you have to press the control key. And with the left mouse key, you have to click on the second module area, and then both are marked in light or mid blue. And then the button above is activated, configure module areas together. And if you click on it, then it's a kind of merged here. We have building roof area south and the second one with the mounted systems. Yeah, and then it's the same like in a 2D planning. You have 3 options to find a suitable configuration, to find a suitable inverter. You can ask for a suggestion. You can calculate all possible configuration, or if you're a pro, then it would be also possible to enter the manufacturer of the inverter, as well as the inverter type and the string length directly. This is also possible. Yeah, we again would like to ask for a suggestion. Therefore, we have to pre-select some inverters, because otherwise we have more than 6,000 inverters or inverter types available. And if the program tries to find the best configuration, then it could be that you have problems with the RAM, because the huge number of possible configurations. And as you can see here, we would like to use now inverter from Furnace International. As you know from last time, there's an action bar, and with this action bar, you can deselect or select all suitable inverters, which are visualized here with these green hooks. And if you have here the other sign, these are non-suitable inverters. This could be due to the number of MPP trackers, or due to the AC power rating, that it's too small or too big. And so we have now selected all the suitables. Click on select, and if we then press the button suggest configuration, here we are. Now we have the Furnace International Sumo 1503-M. It's an inverter with 2 MPP trackers. On the first MPP tracker, we have 2 strings with 22 modules each, and for our mounted system, we have 1 string with 12 modules in series. As you can see, everything is fine. We have here green hooks, that checked very well. And as I've showed you last time, here you can see the design range, how many modules you have in series minimum and what is the maximum number in series. In our case, is 4 strings with 15 modules. And yeah, if we, for example, change this number here to 7, then you get immediately a hint that something is wrong and you have to check your configuration. One reason, of course, is that we have 56 modules on our two areas, but only 51 are configured. And the more important information is that we have not reached the voltage, the MPP voltage range of the inverter, because it starts at 200 volts and we have only reached 186 volts. And if you click on this triangle here, then you can see, okay, here this is shown in this bar graph here, that it starts on 200 and goes to 800 volts, and we are below of this, and it cannot be used properly here in this area of the inverter. Okay, then we have to change it back to 12. Everything is fine again, and we can confirm it's okay. And here we are. These are our 2 strings on building number 1, and the third string here, the MPP tracker 2 on building number 2. And if you would like to edit the configuration a little bit, which means the direction of your strings, and where the string should be start, and if it's what is the course? Is it's a simple course, which means we start on the lower left-hand edge and go up to 2.3, and then we go to the next row to the bottom, and again up and down and up. This is one option you have, that you can change it to meander. That's it's like a river or like a snake. If you change here from simple to meander, you can see that there will be change. They go up, then to the right, down, then to the right, up, right, down, and it's like a river. All these options are possible. Horizontal direction, and the other one was a vertical direction. Okay, I think that's it. Now we go back to show you how to create screenshots, that you have a nice overview of your system. You will find here different view options, north, south, east, and everything you want with the trees in between. Or you can also use your mouse wheel to zoom in, zoom out, and if you press your mouse wheel, then you can rotate here on the horizontal axis, that you have, if you want, the sky within the picture. And then you will find in the upper icon bar, there is a small camera icon. If you click on it, you will find the shutter release, and you can do screenshots. And these screenshots you have created here, this you can take as overview picture for your presentation, for example. Via right mouse click, you can set this as overview picture, and so the software knows this is the one the software has to use. Okay, then we close it here. And now we would like to adopt the data to leave the 3D visualization. You have to press the project administration icon here on the upper left-hand side, the round one. Then you have to click adopt data. And of course, this data we would like to adopt. And we also would like to do a yield simulation. And this is now the time where the real shading ratios will be calculated. And we have to press an OK.
Yeah, so that's right. So now the real shading analysis takes place. So the software looks for every simulation step. Okay, where's our module? To which direction is it facing? How's the tilt? Where's the sun? Are there any objects in between them? And if is the module shaded or not? And also if parts of the modules are shaded, then the software decides if a bypass diode has to be used, and how all this changes the characteristics of the module, and also how a shaded module influences the rest in the module string, the MPP tracking of the inverter, etc. So it's very complex and very accurate, a bit like in reality. And the more shading objects, of course, you have, the more modules, That's the longer it takes. This was relatively quick here now, and we already have now calculated the results by clicking on the calculator icon. And here in the detailed results under simulation, you can find the influence of the shading on the yield. Yeah, it's here the yield reduction due to shading. And in this case, it's about 10%, I would say, that we have reduction due to shading. Yeah. Okay, so that was the classic planning. We now come to the more modern ways. The first one is the planning with the maps. So you can use one of the providers in the software, or you can use your own map. You can see what we will plan. We will want to use an own picture here. Here in this window, or maybe we can go back here. There's you can see the address of the installation, and if you enter address here, then the software automatically focuses on this address in the map window where you select your map view. If you don't enter anything here, then the software uses the coordinates of the selected climate data record. But you can also enter address later. Yeah. Okay, so let's go to the 3D. Click on Edit. And now we have to select another planning mode. This is the map section now. And if you want to use the maps which are included in the software, then you have to click here on New Map section, for example. Then the window will open, and on the right-hand side you can see the different providers which are available. Currently we have Google Satellite. There are Bing maps available. So this is the ones from Microsoft. There are some local providers for Austria, for example, here, or also for Germany and Italy. Denmark is available here. And now you have to decide, okay, what provider I want to use. Depend on the resolution, of course, on if it's a good picture, etc. It's up to you. You can see there's an address field. Here now we have the address which we have entered at the project in the project data field. But you can also enter a different address and then search for it. You can rotate the maps by using these buttons here. And you can zoom in, zoom out. It can also be done with your mouse wheel and the right mouse key. It's like in Google Maps. You all know the function, I think. Okay, if you have your view you want to use, then you just click here on select on the lower right hand edge here, and then the view is automatically adapted here. And also the scale and the orientation of the map is taken from the provider. The information is automatically it's provided by the map provider, and we can just use it. And then if we would press on start, then we would open the 3D visualization, and then we have to draw the outline of the building, etc. But we want to use our own picture. You can use a digital image for that. So we click here on load from hard drive, and we have to search for our picture. And this is the one, it's the ground plan here. It can be JPEG or bitmap or PNG, whatever. Then we open it. Problem now is it's just a picture. It only includes pixels, so you need one reference measurement. You have to scale the building. So the current scale which we see here, it's from the previously selected map. So we click on the wheel icon here, and now we can see here there's a blue bar here, blue line, which we have to bring to a known measurement. We just click on the edges of the line here and then bring it to the reference measurement. Then it's about 360 pixels.
62, yes.
Now we have to enter the dimension here. It's 13.82 meters. In this case, so we enter this, and this defines the scale of about 26 pixels per meter. What else do we see? We see here a north arrow, an arrow to the north, and it goes to 320 degrees. So we have to remember this. And now we can press OK, and the scale is automatically adopted here. We just have to enter the orientation. So orientation of the whole map, not the building itself. Yeah. And the north arrow goes to 320 degrees. So we have to enter this. Okay, this is now done. We can press on start. Now we are back in the 3D visualization, and now we have to use the Polygon tool to draw the outlines of the building.
Yeah, and again, you can use a mouse wheel to zoom in as far as you need. And yeah, sometimes here the terrain grid is a little bit disturbing, and yeah, it gives an option to hide these. Yeah, close to the camera icon, there's a small tool icon, and or just click on it. And the second option here, this is to uncheck coordinate grid terrain, and yeah, then you have a clear view to our floor plan or to your floor plan. Yeah, Sixten has mentioned it. We have to draw the outline. Therefore, we have to select the polygon tool. This is the one here, the blue one here, the blue pencil with the blue outline. Sketch a 3D polygon. Just click on it. Then your mouse cursor will be changed to a pencil. And yeah, we need to click the corner points of the outline of the building. And if this is done, you have to press the enter button once, that you are able to draw the ridge. And then the program normally automatically detects due to the outline and the length of the ridge that it's what kind of building it is. So it's gabled roof or a hipped roof. And yeah, to interrupt the drawing mode, you have to press the escape button. And here we are. Now we have a rectangular as well as a ridge. We can make it a right angle. We have not drawn as accurate as we want. Make it a right angle. And again, via right mouse click, you can extrude the 3D object. This means you can give them a height. And normally, in this case, it works. It's a building, not a building with hipped roof. It's a building with hipped roof, not with tented, and it's not a gabled roof. Everything is fine. It's a building with hipped roof. And what we have to do is we have to enter the height of the eave. In our case, it's 3.46 meters, and the roof pitch is 25 degrees. And if this is done, we can confirm it's okay. And it's a very easy option to define your building without entering lots of dimensions and define the inclination of the roof. Now these numbers are not needed anymore, so it means that we can change the texture and make a more realistic view. And here again, we are using the black roof tiles for each of these roof parts. No, not the right, the black one. Okay, here we are. One more. Okay, that's it.
Yeah, what else can we see? We can see some green round shapes here. That are some linden trees. Yeah, so we can also use the polygons to draw some trees here by drawing some round shapes here. Some polygons with a round shape, or almost round. It's not necessary to draw it exactly round. No, looks good. Then press escape, right click, extrude 3D object. Then we have to decide, okay, it could be a tree, deciduous tree, conifer tree, could also be chimney or some arbitrary buildings. What else? In our case, it's a deciduous tree, and then we could enter in height if you like, but I think we let it at 10 meters, it's okay. So we just press OK. Now we could use this copy and multiple copy option again, but if the objects have almost, or the best would be they have the same distance between each other, then you can use another option. This is the multiply object option. So right click and then multiply object. And now we have to define kind of a matrix. So we have one row. So facing right is just one. Then we have 1, 2, 3, 4, 5 trees in the upwards direction. So we have to enter 5 here. And now we have to define the distance between each other. It's almost 4.7 meters in our case. And now we generate our row of trees. Looks okay. if it, we can just close it. In our case, it's not exactly the same distance between each other, so we have to work a little bit with it. But of course, if you have exact the same distance, then it's pretty easy method. If you have the same objects, you just design it once and then just multiply it, and then it's done. Okay. Now we have our rows of trees. We can activate our building again. Now it works the same like for the classic planning. We select our module, press OK, cover the whole area. We could do a shading analysis, etc. Just the creation of the objects, the building is different compared to the other one. We draw the outlines and we extrude it and decide, okay, which type of object is it, and the rest then we activate it, and then we cover it, and we can configure it, etc. Looks the same. Okay, so that's the second option. So the planning with map import. So last one is the one with the 3D model we want to show. So that's the one we want to use. So we go to the 3D, again, click on Edit. And now we select Import the 3D model. Then we first have to load the file, the 3D model file. And here we are. There are different formats that can be imported. Some are pretty exotic, but the most common ones are the wavefront object with the extension OBG, and the other one is Collada with the extension DAE. So most of the CAD programs have export functions to these both file formats. Okay, so it's a Collada model, so we open it here. Now it will be imported. What else do we see? We see here the maximum height and scale. So normally, of course, the scale is included in the 3D model. Then it's no problem. But sometimes, depending on the CAD program, the scale is probably placed in another section of the file, and PVSol cannot find it, or it's not the correct scale. Then you can scale the whole 3D model by adjusting the height. In the next picture, we will see there's also a tutorial available to us to this and how this can be done. Then we have two options. Use as terrain model. We will show it in a few minutes. And the other one is if we want to center it on the surface here. So then we click on Start. So this is the mentioned description, or you can scale the model. And if you click on the link, then you can find a video tutorial how to do this. In our case, it's okay. So we don't redo this. This is now our 3D model. And what is the terrain model here, the option? If you can see, if we go with the mouse over our 3D model, we can see anything because it's black then. So we change this here by right click and then select Edit, and now we use it as a terrain model. Okay, and we now move our mouse over the object, and we can see all the objects which are on the 3D model. Okay, now it works a little bit different. In the previous planning modes, the software was able to detect the areas which should be covered with modules automatically. This is not the case for the 3D model. So for the software, just the hull, and the software don't know what can I cover and what not. So I first have to draw a model area so that the software knows, okay, what should be covered and what not. So we use the overhead view here, and then we use this polygon. It's in the polygon in the 3D model section. So we activate it here. Then we can see our pen again. And now we have to draw, in this case, the outlines of this area, or this roof area, which we want to cover. You can see the blue points. They should be on the area, on the model. What we do in reality is we introduce a new layer, which is slightly above our 3D model. We have to do this because we want to cover the things here. Yeah, but the problem now is that the layer is not really connected to the 3D model. Yeah, so if we would cover it now, then the software would not detect that there are some barred areas because they are not in the layer which we have just created. Yeah, so we have to mark the objects which you can see here with barred areas. Yeah, so we just have activated now our module area here. Yeah, now we are focused on the module area, and then we use this polygon for barred areas here to draw some as it is named barred areas here. So we use this multiple copy option now. Okay, this one, and we close the clipboard, and again use this polygon for barred areas. So left, okay. Then again, copy clipboard should stay open. And this is 1, 2, 3, and 1 is left, number 4. Okay, then we have the chimney. Last one here. Okay. So, yep, here we are. Okay, if this is done, then we can move forward to the module coverage. It now works the same like for the other planning. We select our module and just cover it. Okay, cover it. Now the height of the objects will be considered. Yeah, we can see it if we draw or if we calculate the shade frequency distribution here. Then we will see our percentages here. Yeah, because the layer is slightly above our 3D model. Then you can see also the percentages. And then it works the same. You can remove modules. You can configure it, etc. So you import the 3D model, then you have to mark the area which should be covered with modules. So you could use a new layer if there are some barred areas or objects on the 3D model which are kind of below your module area, module layer, or so your new layer. Then you have to mark them with barred areas, and then you can just cover it or use the mounting module mounting, configure it, and then simulate it. Okay, so yeah, that's it for the 3D planning. That's what we wanted to show you. Hopefully you are now able to plan your own system in 3D. If you need some more information about our programs, then please take a look at our website, www.valentin-software.com. If you have some questions afterwards or some remarks, please write us an email to hotline@valentin-software.com. Yeah, that's it from my side. Take care. Bye-bye.
Yeah, also my side again, and thank you for joining us today. I wish you a nice evening. Take care and goodbye.